Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And, you hear that we got, Champ back with us. So, and what that means is we're going to do a little bit of a recap from last week. And pretty much we talked about rapid prototyping and STEM education. Mm-hmm. So, I don't know. I know you're spending time with family and, weren't feeling good. No. I don't know if you had a chance to listen in.
Yeah, I heard a little bit of what you guys are talking about. I mean, for a little bit there, like you guys kind of, we're talking on sustainability on a lot of the things. A big part of what I'm looking for, especially with rapid prototyping, is the fact that, what is the prototype you're trying to set up? Is it for a project for, something that you're going to be using? Or is it like just to learn a process? Like, or is it just to see, what do we call them? Pipe cleaners? Just to see if your process fits, if whatever you're checking dimensions. Yeah. So it's, for me, I think the sustainability around 3D printing is so huge because we could, essentially, we've talked about it before, Ed, break down the model and, get all the bits and put it into another, like, pelletized form and then run it again and go again. At the end of the day, most of these things are very cheaply made, and if you're making it out of, like, PLA, it's biodegradable, so you may not have to do as many sustainability steps in taking care of these things. But for me, rapid prototyping is huge. I mean, it's necessary for us to. We probably heard the term agile in a lot of computerized, like the software side. But if you want to continuously upgrade and continuously improve, you've got to do it. So for me, I think that it goes without saying that teaching that scientific method and teaching that quick thinking, that critical thinking, and problem solving in a STEM level. What is it, like second to like 8th grade? Starting there, you start building a way to solve problems instead of just a way to find problems, because what I've seen in a lot of education is this is where you find the problem where you're stuck, and then that's the end of it, instead of saying like, okay, this is how you find you're stuck, this is how you find your way out, like this is how you find this is how you do this process, this is how you change it to make it make sense to you, and then from there, because that's how I learned math. Like, I do it my own way, and if it came up with a different answer, that's not how math works. Go and try it again, and keep on moving. But you take that into account with 3D printing, and there's just so much that you can do. You just take your imagination, and you can really make whatever you want.
Makes sense. And, the thing is that's kind of why we do these kind of wrap-ups a little bit when somebody's not here, and they jump in and, give us their point of view. Yeah. And the thing is I don't know, I hate to curtail what we're going to be talking about today, but I don't know if you've seen one of the recent episodes on the YouTube channel CNC Kitchen. He actually has a open source pellet or open source filament recycler. Okay. So you grind down the filament, you throw it in there, and it actually puts on a roll for you.
Oh, so it respools it? It
respools and everything for you, yeah.
That's pretty impressive. I mean, that's sustainability. That's
right.
That's, in my mind, that's what I would have pictured as like, okay, failed print goes in, this, purple bin, blue bin, whatever you want to call it, and then this bin goes back around, goes into this, like we have we could do a hazmat type station, like if you know if it's chemicals that can be, just exposed to the environment like that, or if it's PLA or PETG or something like that, then you got to have a process to like reuse it. Yeah, how to, like it's got. Yeah. To me, I reheat and make my PETG prints malleable with a heat gun just constantly and reform if something doesn't fit right. So I would assume that it's just that easy just to get it back to a temperature and then spool it again. Wow.
You cut it into pellets and you throw in this whole thing and it spins it and shoots it out as a stream. It's actually pretty cool. But, and that whole thing kind of leads us into, this week's, kind of topic that we want to talk about is, MCUs and I guess we'd say the electrical peripherals of a printer or CNC machine or anything like that, of say advanced manufacturing, and the sustainability portion of that. We're talking e-waste, recycling if you need to recycle it, or using it for a secondary purpose that's not used in its current purpose.
Maybe I would say one of the things that I see is a gap in any type of things when we start talking about repurposing or we talk about recycling or renewal. Mm-hmm. What I've seen is say in automotive, if you purchase a battery, you can return the faulty battery for a new battery and get a core charge. Yeah. Maybe an idea would be that if you buy the filament from a certain manufacturer at this point, because everybody has their own way of doing things, that if you send us back this amount and it's sorted, we'll give you a box. You send the box to us, and then we'll give you a percentage for doing that recycling for us. Or maybe we have to look at the formulation of the material so that the material itself is easily broken back down into raw materials to be reprocessed easier. Yeah. But it should be uniform. It has to be. The industry has to adopt this.
Right.
So here's the reason why I agree with you. And yes, Filamentum does this. They reuse, they upcycle things and make them into usable filament. But my one gripe would be, I think it needs to be more proprietary or brand based, because for instance, 3D Solutech is a brand that I print with a lot. eSun is another popular brand. They both make PLA. Their PLA consistencies are not the same. So my thing is, I'm pretty sure there's not just Filamentum, but a couple other smaller startups and things like that. That let's say you send me 3 bags of PLA. Doesn't matter what brands they are. You're gonna get back something that looks like an amalgamation of all these colors, but it's gonna be technically PLA when you get it back. Yeah. And I think that the problem is that in a lot of cases you risk, because you're creating a new material, a new polymer, because you're mixing 2 other ones, and in some cases the mixture isn't as clean. But for the most part, it's like diminishing returns. For the most part, you can still use it, and if you're not using it for impact prints, of course, PLA, please don't use that for any impact prints or weight carrying or anything in the sun. Right. But yeah, it'll degrade it. So if ABS I'm using or TPU, it'll still be rubbery, but it probably won't have the same consistency. Just like how you have a rubber band that becomes brittle after some time.
So here's what I still feel like this. That's the problem. Yeah. There should not be a different formulation for PLA. Yeah. There should be a ISO standard or something that say PLA has to consist of this. ABS has to consist of this, because we want everything to be renewable. We want everything to be able to be upcycled. This is the new standard, and if you do not follow these standards, then you will have to pay some e-green or whatever we do, e-waste or whatever. In my opinion, that's the problem.
Well, I don't think we have
it's too many. It's too many. Well, I'm saying, I don't want to regulate, but you will be penalized if you're not part of the group.
That's regulation.
Yes, it is, but it's not writing the law. It's just saying that it's not writing the law. Say that you have thou shall do this. It's saying if you have the option to not do it, but if you do not, then like the same thing you do in a place that checks for emissions. Yeah. Then you have to pay some fine for those emissions.
You have an overhead where if you're polluting more than No, I mean,
your footprint. You're responsible for your footprint. Yeah.
But the thing is before we turn all the filament into California, we start
my filament, my footprint.
But imagine, just imagine 1 second. I'm gonna let you get that. Just 1 second. Just humor me just 1 second.
I humor you all the time.
Just imagine. Just imagine if you could take any filament, no matter the color, and it was the same. Essentially, it's the same other than the dye. Yeah. Other than the thing that gives the pigmentation. That's the only thing that's different. If I could send those things to any company, and that company can dump it into a magic machine, and the magic machine can add whatever it needs to add to give that strength that has to be for PLA, ABS, or whatever that product is. Do you know how much money they could save? The profit that they would make if they would keep an ecosystem that would do that. Instead of, hey, I want a proprietary this, and corner the market.
Mm-hmm.
Corner the market ain't doing nothing but filling up the rivers and the ocean over there by India.
Yeah.
With
But
stuff that people can't
go ahead.
work on.
I just had to say that.
Well, the thing is if you think about it, that majority of the filament that you can buy on Amazon and other places is not made in the U.S. So that's where it turns into the issue of having to have a global standard.
That's why I said ISO.
And I can tell you a bunch of countries that don't follow that.
Yeah, it's true.
But so that's where your problem lies. And then the thing is, if anybody wants to skirt the ISO standard, they have it produced there and they bring it back.
But there's ways around that too. There are countries that try to do things with blood diamonds, right?
Yeah.
And for the most part, yeah, they can do things in the black market. But if I want to be a legitimate company, then normally it's frowned upon.
Well, the good thing is like I think it's called like we'll get to our topic of the week eventually. I think it's a company called My Filament. I saw them on YouTube the other day. I was looking into them. They're a U.S. based company, and they said, okay, cool, this is what we're gonna do. They're eventually going to get the cost per roll down to $10 a roll, made here in the U.S. However, the first thing they're going to release is clear. Like, why? Because that is the original color that PLA comes in.
Yep.
And they're like, we want our customers to audit us. Tell us where we're screwing up at. Send us back the information. Let us improve and let's build on this. And then they're going to slowly but sure, and they have their own print farm, so they utilize their own print farm. You know, the good thing is about most of your U.S. manufacturers, and I know we do see some in the Chinese market, you know, that if they produce their own parts, they have a pretty good, filament. Pretty much like if you go to the Czech Republic, you start getting into Prusa Research and Prusa Filament and stuff like that, where they produce their own stuff.
I think it's known for quality.
Right.
Though.
I think if the company produces parts or produces prints with the filament that they make, it produces a higher quality filament because you have to use it yourself.
Yeah, I think that's
yep, because your quality control.
Right.
Yeah, I think that's the thing is like that's exactly right. You become the quality control, and if you have to use it, you need to make sure it works.
And you have to find your own recycling function because you ain't gonna throw it all back into the into the bin.
I mean, I think currently there's not. So first off, there's not a standard like that, of course, which is why we're in the state. I think in a lot of cases too, people use so many different. They use more chemicals to make these colors and things like that, and it becomes a dangerous thing. Like if you mix two things that are PLA and they use like a different chemical or reactive chemicals to make the color that they have, and you put them together, you might cause some unintended chemical reactions. But like, yeah, I mean that's the point. You avoid it's safer. You make it more sustainable because you're making exactly what you need instead of making a lot of everything. So you have it. I mean, to me. It needs to be done. It needs to be a standard.
I agree with you.
So here's the argument: pellets or rolls. I say if we got rid of rolls and we went to pellets, standardize the pigmentation. So here's the standard colors for pigmentation, just like sort of like a copier or sort of like a printer. It has some things that make the colors.
Yeah.
right.
We have these base colors, but the base is the same. Everybody has the same base pellets.
I think the pellets work better.
You go to a pellet system that works somehow where it can generate. Maybe the plastic is just molten and we use a heated jacket hose, and a heated jacket hose delivers the material to the hot end, and you get everything and you get rid of the roll. So I can just basically have a container that dumps in the pellets. The pellets do what they need to do. I get molten material. The molten material with a servo and some type of auger system to
push it.
So basically, we would take injection molding principles and turn it into 3D printing.
And that's where I think we finally hit a point where we can, take the filament conversation and run right into the controller, side of the house, because you start dealing with pelletization of your filaments and stuff like that. You start having to have more motors for auger movements and stuff like that. So you have to have a larger MCU. And the good thing about that is technically, if you look at it cost per pound, your cost per pound for filament is cheaper by the kilo than it is per kilo of a roll. And all it is just a little additive. However, that's when you start getting into the fun part of, when you start doing your CF additive and stuff like that, which might be easier, but when you start really talking about your MCU configuration, that's when it will get kind of interesting, because most of us are using Clipper. Most of us are familiar with the Clipper ecosystem, and I don't think there's anything in the Clipper configuration that tells me to turn my auger on.
You can put it in.
However,
unless that's considered the extruder, which I think it might be.
You can treat it like it's C# and name some things and kind of make it. It wouldn't be perfect, but you can treat it.
I think it's
there's some smart guys that came up with Clipper. Didn't exist a couple of years ago, right? Yeah. And everybody was using Marlin.
Yeah.
And then they came up with Clipper, and look at the advanced things they did with Clipper.
Mm-hmm. I think I think all it is an extruder, because I think they look at the auger as an extruder, and then they go that way. Everything's piped in via vacuum, into the hot end, which for me, honestly, one of these days, sometime over the rainbow, I guess, we'll eventually build, because I have open source plans to build, an auger type 3D printer, nozzles and stuff like that, and actually, use pellet.
Yeah.
And a lot of times you start talking about like robotic 3D printing. You're talking about.
Well, here's the thing: is that I don't know if you ever dealt with gluing systems.
A little bit.
So basically, gluing system has some of the same properties of plastics.
Yeah.
Elastics.
Like that,
Elastometers, I think it's.
Yeah. Elastometers.
Here's the thing: if I have a heated jacket that's over a hose, I can have my system that's delivering the material just to the hot. We don't change nothing with the hot end. By the time it gets to the hot end, it's cooled enough because of the jacket. So, let me take that back. The hot end will change because we don't need the gearing now.
Mm-hmm.
So we get rid of the gearing. So it would be actually another motor at the head, and it would be a motor that's delivering the material from the auger. And this can all be servo controlled. Now getting feedback, and I can control the rate at which I put down that bead of material. I can also do some things with pressure inside of this hose, and I keep a consistent pressure to get a certain amount of nominal flow of that material going. Which means the head can move faster because I have a servo that can keep up with the motion control system.
Yeah, I mean, we kind of dove right into the MCU talk and kind of talk about control units and stuff like that. I mean, this is microcontroller. So, I mean, at the end of the day, what you were saying, Nick, is totally possible. You can add as many sensors as you really want to this.
Right.
There are things on the back end. When we made we did our Git repository pull, we pulled a set environment list, and that's where a lot of those things are generically set. We have a lot of generic names for things in there. So, dude, we can make it check anything really at the end of the day, but when we boil it down to we're talking about microcontrollers, we are focused on 3D printing, so we're looking for microcontrollers that have motor connections, that may possibly GPIO pins. We're looking at a serial port to connect to the printer. We're looking at possibly internet jack. If not, you're using a Raspberry Pi or something that's using the internet. And that's what the serial connections to. These are the basics that I would say you need for it. One thing that I immediately thought about was the software side of things and kind of why we would need that. What did your Ender 3 or my Ender 3 come with when the motherboard or the MCU when it first came in?
What, Marlin?
Yeah, so it came with Marlin, but it was a 4.2.2 board.
Right.
And there's a reason that we wanted to upgrade
Silent
the
stepper.
So the Silent Stepper is one of those things because it's got drivers that your standard didn't have. But there's the CPU is the big difference.
Right.
8-bit versus 32-bit. And now all of our printers now are coming standard 32-bit because it takes so much processing power to do the movements that we need to do that it's become a standard. So we talk about those inputs, 32-bit CPU is a requirement too.
So now I'm gonna blow your mind. I'll blow your mind. We're talking about MCUs, and microcontrollers are good for certain applications.
Mm-hmm.
So if we're talking prosumers, we're not talking hobbies.
Right.
Why is it not possible to take a micro PLC, so like a S7-1200?
Like a click and stuff like that too?
You can.
No.
You make it work with it.
You take an S7-1200.
Yeah.
You have a servo controller
Mm-hmm.
that talks through a data. It sends data.
Mm-hmm.
The servo controller does all the motion control.
Mm-hmm.
The PLC, which is the S7-1200, or you can use Alan Bradley's setup, MicroLogix. But it has way more computational power for that type of thing, far as being a traffic cop.
Yeah.
And it's pretty simple to set up.
And the new 1200s, if I'm not mistaken, I think already have the logic controller on board to understand G code.
Yep.
I think that's why
That was the last. I think what was it, the 1200.1 update that they did to the Siemens controllers. It was 1200.1, included the G code manipulator on board, which is actually pretty cool if you haven't played with it. But the one thing that and I love the idea, honestly. I think the one thing where you get kind of some of the fun is because technically, if you really wired it correctly, because I believe it's Siemens that has a CAN bus attachment.
Yeah, you can do CAN bus. But it's not necessary because ProfitNet.
Right.
You don't need the CAN bus for this reason.
The reason why I say that, and the only reason I say that is because sometimes your hot ends, if you're not driving the extrusion process, like the extrusion fan and stuff like that, is all over CAN bus.
But
to reduce the load.
So here's the thing: you don't need it,
right?
Because if I go to a servo system,
right,
the servo has feedback. I don't need something to do something with CAN. You can. I'm not saying you can't use CAN bus.
Yeah.
CAN bus is an excellent system for microcontrollers.
Yeah.
If you have a microcontroller based system, you want CAN bus. But if you're using a PLC or anything like that on servo controllers, you want ProfitNet. You want something that has the capability of handling big chunks of data, and you're getting feedback.
Right.
You're getting real-time feedback from a servo that can adjust itself. Yeah. And that servo accuracy is way better than any stepper motor. A stepper motor cannot even get close, not even in the same realm. Yeah, you're talking robot control.
Oh, I know.
Yeah,
I know what you mean. Yeah,
I think we've talked about the difference before, but I mean, so actually looking at if listeners aren't sure about the difference between servo and stepper, like it's like having if you're familiar with sine waves, it's like having a sawtooth versus the whole sine wave. Like you're not going to get that full movement. You can't get the full movement unless you work with continual. You change the step pattern. It's called a stepper motor for a reason. It's a clear step. So I mean, at the end of the day, if your robots are getting ran by a PLC and they're using their servo motors, I think it makes sense. But if you want to take readings off of that hot end, you want to make sure that your extrusion ratio and your flow is right. You're probably going to need to take readings at the extruder.
Still can. The PLC, as far as I/O, is an I/O monster.
As long as see, that's the thing.
It can do
that's
analog.
Why I brought up
it can do discrete, or it can do analog. It can do pulses. It can do pulse counting. That's the beauty of a PLC. It has a microcontroller in it, but that system is able to do a lot more things than a microcontroller. Now we're getting out of the realm of hobbyists. We're talking about super.
What you're telling me that people don't have a KUKA robot in their living room, just getting them like sandwiches out the fridge or beers?
Well, and that's the other
where's
thing.
that ever been?
Yeah, here's the other
there
thing.
you go.
Here's the other thing.
KUKA Island to get you the beer out of the fridge.
I could get a Yaskawa. I could get a Yaskawa robot controller and robot that can handle multiple robots.
Oh, okay.
And now I can also bridge the gap with communications between that, the servo controllers, the mechanisms that you want to do, the things with the 3D printing, and far as the Core X system, I got a robot. Basically,
you don't have to worry about Core X.
And I can make any movement I want to make. I can make exotic movements.
It would be more like the Delta robots that you see because of the 6 degrees of freedom. Because when we talk about our standard printer that we have at our house, we don't have the same. Which 3 degrees. That's it. 6 degrees of motion like that. Printing and being able to process the G code for that, you're absolutely. I don't know if a 32-bit would. I mean, it would probably do it, but it would chug along, and your print's going to be slow. But if you have a PLC with an HMI or something that's more powerful, there's no like the sky's the limit. That's why they're building houses and stuff like that.
So here's printers. The thing. I play Edwards Advocate. Now let's get back on point.
Well, the thing is that's
the MCUs can be stacked.
Yeah, they can. And the thing is for me, when it came down...
Oh, I'm sorry. Go ahead.
When it came down to the Voron, that's when I went to CAN bus. Because for me, it was reducing wire streams, wire loads, and stuff like that.
That umbilical cord that's just sticking out now.
Right. So, but it's easier to do, like, I'll tell you one thing. It's every time I do a hot end change, I change my hot end out, for a mosquito. And it was so easy. It was. I didn't have to pull a bunch of crap apart. I didn't have to go unwire my printer. I pulled about
this guy
3 inches worth of wire out of the printer and just put 3 inches of wire back in the printer with everything attached to it.
Yeah, try to do all that with a mini stealth burner, not a normal or afterburner, not a normal. The baby one, I can't move. Like I gotta take everything apart to put back together.
So Chet was talking the GPU.
Yeah.
So basically, most modern cars have multiple microcontrollers in them. Via CAN bus, these systems talk. So you could essentially have a controller for just the heating and the temperature and all of the signals.
Yeah.
And you could have an MCU for just the motion control.
Yeah.
And by separating the two and having two boards that communicate via CAN bus, then you could get near to what, say, a small scale PLC could do.
Yeah, because the thing is a lot of that's coming from Big Tree Tech now.
And this is how we're running mostly, anyways. That's why we pulled the processing off and put it on the Raspberry Pi instead of putting it on the MCU. The MCU should just be a call and response.
Yep.
It should be real time. Like this is my reading now, and your CPU or your computer, your HMI, whatever that's recording this data should be the one that's like, okay, well, I need you to go this. I need you. You're this far out of spec. I need you to go up or down. And the MCU should just be the response.
Which that now leads me to this question: Big Tree Tech, came out with a motherboard that has the Pi type of interface already pre-built in.
Really?
So it's a bolt-on. It's included in the package when you buy it. It's plug and play. Everything's on the same board. You don't have to worry about multiple boards or anything like that. Everything inside of it. Then, what is it? A couple of weeks ago, they released the Kraken, the motherboard.
People don't know what the Kraken is. Can you just give us a background?
the big sea monster.
The size of the sea monster. Yeah. For the Big Tree Tech Kraken, it's built for the new Voron printer that's coming out next year.
Okay.
Yeah, it's gonna have 4 beds instead of 1. And it's also gonna be all on ball screws.
Oh, we talked about that.
We were talking about that at work. But the thing is the Kraken itself has 8 driver motors installed, pre-installed already. It's 24 volt, and it can handle 2 power supplies because the new Voron printer is going to require 2 power supplies of the same size that's running mine, and not the 24 volt ones in the middle. That one's just for the hot end. So
pretty much have 2 printers.
I wonder why they just didn't go to, like you remember the old PCs we used to build that had multi-tap voltages. Why don't they just go to a 48 volt power supply?
Well,
get a
modular with the 48 volt power supply. Kind of like some of the Humvee systems that split off.
Yeah, the good thing is about this one, it is 24 volt and it's 48 volt compatible. Okay. The only reason I think they did the 2 power supply on the demo model is for kick down voltage. When you start kicking down going into your hot ends. Because your hot end can't handle, the hot end board itself cannot handle 48 volts.
Yeah, but they could just use a voltage. They could use a voltage regulator.
But I think for them it was just easier to do the startup with. I don't think they had a 48 volt power supply available because it was a US based printer. So I think they're working on getting those developed.
Yeah.
So that's coming out for the new Voron. It's also if you look at the Big Tree Tech Kraken, the board itself is absolutely insane. It's a monster.
Yeah, what's it? So what's its predecessor? The octopus. That's
The octopus.
The closest thing that's
it's an advanced octopus.
So and the octopus only had 6 drivers, right?
Right.
6
so
motor spots.
I think you can still pull it up on Big Tree Tech. If you look up, I know since you're sitting in front of your computer, look up Big Tree Tech Kraken. And I hate to hijack it with this nerd stuff, but it's a board that takes everything everybody's wanted pretty much and made it an oversized board and says, "Here you go."
Yeah. See,
it's not like
I don't like the I gotta have 2 power supplies because
I think that was only for the demo.
Oh, okay.
I don't. They haven't released the BOM yet. The BOM for the Voron printer is coming out towards the end of the year, and they're still working on that to get it down to 1 power supply.
Oh, okay.
So they're still working on it.
Yeah.
However, the board itself can handle 2 power supplies. It has the ability to do a kickdown voltage if needed.
Okay.
Which is absolutely awesome.
And it just curious, just keep on this track. Like from what I've seen from even industrial or even commercial or even the PC base, you can simply put in voltage regulators.
Yeah.
And the voltage regulator can either be a smart regulator where when I plug up a device that's certain impedance, it say, hey, this is a 12-volt device.
Yep.
Hey, this is a 24-volt device. To me, it would have been nice, or it would be nice if they incorporate a way to say, hey, I have capabilities to run 48, 24 volts, but here's a tap for this voltage for this type of thing. Here's a tap for this voltage for this type of thing.
Makes sense.
Or move a jumper.
Yeah.
If you move this jumper, then you can get that configuration.
Yeah.
Then I don't have to take up space with 2 power supplies.
Right.
Or make 1 big power supply. There's 2 power supplies.
Yeah, that makes sense too.
That's good too. Didn't take up less space.
Right. You know, and it's funny because, you know, as we get into the bigger and badder and stuff like that, when we start talking about machines, you know, Vorons are considered hobby machines. You know, well, prosumer machines, I think now is what we're really calling them. But you start getting into, you know, some of your commercialized printers. But then you really start getting into the fun of when you start getting.
I think it's called Manta.
Oh no, that's not it yet.
Well, this one's got a whole bunch more than the octopus though, but I didn't see any pictures of it. But I mean, they're coming with the ability for you to load Linux onto the board, the MCU. So this has the ability to run your Linux environment. If you want to do like a GUI environment, you can run one. It's probably going to be some type of form of Armbian, like or Linux or something like that.
To be honest with you, today it's not even necessary to have a Raspberry Pi. And I'm a big proponent of Raspberry Pi. You can get a thin client, and a thin client is 10 times powerful than a Raspberry Pi.
Yeah. I'm gonna be very honest with you. I have an Orange Pi. It's there's a reason it kind of benchmarks is similar to a Raspberry Pi, but was a little bit underwhelming in some sorts. For what I'm doing, I don't need the power of a Raspberry Pi 3B plus. Not that much.
Arduino has already started developing their own board that does PLC control, and there is an industrial version that they have now.
Okay.
Yes.
Well, I mean, and this is the thing too, because we're talking about MCUs. I mean, Big Tree Tech is the one that I kind of swear by. Like, of course, the Octopus is something that they make. It gives you more plugins for your motors. The SKR Mini, I'm using the version 3 on both of my Enders as well as my Voron. So there's a reason we use those. It's about the architecture of the board, and it's about ease of use. Like these pins, I got this pin out.
Yeah,
and it's simple.
That's really what it is. Cause
it's very generic. Like
if you even look at the stepper controllers that are out there that you can get. The stepper controllers, like I said, you just basically hook the stepper controller up, and then you can interface to the stepper controller. And you're talking about power. Not only can it do DC, some of the steppers can go, you know, just basic DC. It can go 12 volts, 24 volts, 48 volts from a board.
Yeah, and that's the thing is like the price, because we're getting so many more transistors on the boards, the prices are lowering for these MCUs. And this,
which is nice.
These control units and these Raspberry Pis and things like that. So
why did somebody try the i7 with this?
You can.
It's overkill, man. What?
No, I'm saying like when I add the i7,
I'm
adding some capability.
Yeah.
I don't want it for a GUI.
Yeah.
I want to take that i7 and figure out how to use the CNC capability and G code
Oh, you want to make okay?
How can I do
That makes
enhanced
more
G-code?
sense. I was gonna say if you're trying to just use an i7 for the same stuff that we're currently doing, that's like getting the F1 or an F1 racing track just to take the highway to work.
How can I get into additive manufacturing and start doing things with metal?
Yeah, no, that's the thing. That's desktop metal printing it needs to be the next best thing. And right now we have lost PLA casting, we have CNC machining, which is subtractive, unfortunately.
I tell you, the setup we saw, it totally blew our minds. Like I said, and we kind of jumped a little bit, but additive, subtractive together.
That makes sense.
It's crazy.
Yeah.
Imagine if somebody can do that.
Yeah.
On the level of a kitchen table.
Yeah, and
or the size of a microwave.
Yeah.
And the thing is to get into like pure additive, like pure metal 3D printing and stuff like that. Like what we saw is what $100,000 for the lowest model.
Yep.
So people can get into it. It's expensive to get there, and it's a little less messy than lost PLA casting, to be honest with you.
And it's what can you do with it?
Right.
If I have something that's broken and I need to repair it, I can use that to repair something, to build a material up and then mill it back down to spec to repair something that I have to use on a car.
Yep.
Yeah. No, that makes sense.
And I think that when you start talking about and I know we're kind of going long in the tooth, but no, we're not too bad. When you're talking like MCUs and stuff like that, you're talking, and this is where we go back to the cost thing. The cost of the MCUs that we're getting from like Big Tree Tech and a couple other places,
I can't argue with that,
are dropping.
Yeah,
the prices of
we were just looking at it.
You got me there. You got me there.
The cost of a Raspberry Pi is increasing.
Yeah.
And it's weird because I know it's supply and demand, but we're seeing more of we're seeing a higher supply of the MCU boards to feed these 3D printers that people are buying now, because they understand what they're used for. But the thing is, they're also not just used for 3D printers. They're used for open source robots. They're used for open source CNC machines. They're used for the dog walking robots out there that they've got now, the 4-legged robots. The planes, drones, and everything. They're all using all this type of stuff. So the supply is there. A steady supply is coming. But that's where it gets into the funny part of. You got like Raspberry Pi over there, in good old England, that's still trying to figure out how to pipe out 200,000 a year.
Yeah, but the thing I do give Raspberry Pi and Arduino, it actually started, it was a STEM based thing that they came up with,
and I think that what they're doing is great. Yeah. Don't get me wrong.
Education wise, I think it fits.
And I think they're doing it right by selling it to who they need to sell to first.
Yeah.
And the good thing is we're also seeing a lot of projects go away from the Raspberry Pi and go to the Arduino, leaving the Raspberry Pis open for STEM education. I do like seeing that. Or a lot of people are going to the Raspberry Pi Zeros.
Yeah.
Maybe not the Picos, but they're going to the
I like the Picos.
The Zero Ws.
Yeah. The Nanos.
Yeah. Like I've been debating on building an application for the vehicles, because my neighborhood has a bad habit of people breaking into cars. Is setting one up inside of a vehicle that can watch all your windows, and all you're doing is using Raspberry Pi Zero.
Right. So I got a little distracted here looking at some of these MCUs and stuff from Big Tree Tech, but it looks like the Kraken is fairly new, so keep an eye out for that, guys. If you see it coming soon, it's pretty crazy. It's a giant board.
So what's the price point between, say, the Octopus and you said the Manta and the
Kraken?
And the Kraken. What are we talking generally?
Kraken hasn't been released yet.
I didn't see a price point for the Kraken.
So what about the other two? So I guess the other two have already been released.
Yes.
The Manta and the
Octopus.
Yeah, let me grab you the price point of the other two.
I'm running an Octopus on my Voron in there, and I think I paid $85.
Yeah, it's not bad.
Not even $85 on it. I've had to buy it twice.
Manta for Ender 3 is $45. If you want to get anything that's bigger, it's going to come with more parts. Of course, it's going to be a bigger pocket. You get HMI and stuff like that. Yeah, with the HMI, with the Manta board that has internet capability and the stepper drivers, is $80, $79.42.
That's affordable.
That's not bad.
I don't.
Yeah.
I mean,
with it looks like a touchscreen board. It might not be touchscreen, but it looks like a pretty good interface. Better than the standard that you get. With
I mean, like I said, it's that's really for the price.
Yep.
That's not bad.
And see, the thing is, all those can run ROS.
And yeah, it even says here for Clipper or Octoprint, perfectly for your Ender 3, and it tells you exactly what compatibility it has with some of the other steppers and the drivers.
And so, just in case we have somebody, well, what's ROS? Explain them in briefly.
Robot operating system.
Okay, there you go.
I was gonna say briefly.
Yeah, briefly. We don't want to go down the rabbit hole, but I'm just saying, in case somebody listening, or what is ROS?
It's robot operating system. It's an open source, robot control system.
This is like where the makers kind of like operate and live is an open source. I mean, we can make things proprietary, but that's not how we got to where we are.
Right.
I learned things. I think there was a phrase that I had in college that came up a lot when I was studying physics. Is Stephen Hawking? He said, "I'm not the smartest person that ever lived. I stand on the shoulders of giants." So I mean, he had Galileo's information. Shakespeare even writing literature. You take all the knowledge you gain and build up. So
and you get quality control built in there too. Because if you allow people to look at the source code, maybe they can figure out.
The thing is,
other functionality.
Work with these guys, support them, support what they're working on. ROS is 100% open source, and you can work with those guys too. If you have a maker that you like, that just, hey, guess what? Let's partner together and build something great. Partner with them. Work through their process. Both make a little bit of money. Have a little bit of fun with it.
I accidentally clicked something. I was reading articles, and it's talking about mind reading AI. And they're like, don't worry, it's non-invasive. But you said mind reading though.
Right. Well,
does it look at your search history and go from there?
No, mind reading probably from like
it looks like it's just
they take
words.
brain waves.
Yeah,
that they've said, hey, this is the
they're
activity
like, think
that happens.
of this word, and then we're like, this is what your wave looks like, and then it makes it that. That's what it looks like.
Yeah. And we'll eventually get around to AI, like I said, machine learning.
I gotta close the laptop because we'll just keep looking. Look up scholarly articles. Read them.
So I'd say final thoughts on just MCUs in general and we'll just go around the table.
Yeah.
What do you guys think? How far we come? Where we started, how far we come, and where we're going.
I want to go first. So where we started was very hands-on, and I think what was the first 3 prints was RepRap was the first company or group. I don't know if it's fully a company that started making them, and they were using weed eater wire and trying to make things using old control units and making things like very, very whatever I have on hand is what gets made. Where we are now, I'm surprised I didn't say anything about it sooner. I can print my PCB board on my resin printer, so that's where I am now. I can make my MCU on there. Well, I can't have all the same, I'd have to solder in, of course, we get components and stuff. But at the end of the day, we've gotten so far as I could make my own at the house if I wanted to. But there's a standard. We talked about the price point is very low now. It's easy to get into your house. I prefer the SKR3 or V3 Mini 3 or whatever. I'm not sure. There's a couple 3s in there. But at the end of the day, it's a 32-bit motherboard. I've had nothing but success with 32-bit motherboards with the size of the prints that I'm using. So I think if I thought about it from my perspective, I've been happy since I went to the silent board. Made the print quieter and then made giving the capacity to process. That should be enough for most people, right there. However, we talk about where should we go in the future. Companies like Big Tree Tech are pushing for more and more connections. Of course, we need those things so we don't have to include extra hats and get extra PCBs to extend the board out. But at the end of the day, going into the future, we saw it already. We split these processes because we wanted to take away some of the wear and tear. We're getting to a point where it's not that expensive to put it back on and make that processor stronger. So now we're kind of getting back down to where, like the cell phone thing. like we had cell phones that were bricks, and they're getting down, and they got so tiny, and then they started getting bigger and bigger and bigger because now we have more information we need to put on it.
Mm-hmm.
So I think we're like, it's a very good analogy. Is we've gotten, what do I need to start printing, down to a set, like couple key pieces, extruders, hot end, stepper motors, and then now we've started to grow in, like, okay, why can't we add a couple more steppers? Okay, why can't I add another sensor to tap the bed? Okay, why can't I add a sensor that's going to read my ambient temperature in the enclosure? So we're getting to that point where now everything's growing again. And I mean, honestly, there's still more than one board being used for a lot of these processes, but it's getting to a point where it's going to get all condensed again into one unit. So, I mean, that's at least what I would see. And that's, I mean, I feel like I don't want to speak for everybody, but that's...
So I'm probably a little bit newer to 3D printing than these guys, but I'm probably a little bit more experienced with MCUs than they are, because I've been dealing with these all the way back to the Motorola processors that we used in Allen Bradley PLCs, the same ones we used in the Step 7 PLCs.
Did Nokia or Alcatel, I'm not, what is it, Alcatel-Lucent or something like that? I feel like they used to make PLCs too. I could see you with the Nokia phone. That's the only reason I bring it up.
No, that's it.
What, breaking concrete and drop it?
So the major players as far as PLCs is hadn't really changed.
Yeah, okay.
As far as the microcontrollers like Atmel, I think it's Atmel, and Motorola, and there's a few other brands. But in general, the Motorola type or the MCUs have been at 32 bits for a long time. And normally when a person goes to a lower bit rate, is either it's not necessary or the cost point.
Yeah.
So what I've seen from what MCU capabilities are is we're using them different is where we are now. I think in the future what you will see is that you will have a MCU that will be able to have multiple MCUs in one package. And I won't have to have, so the same thing I was saying with the CAN bus system, I will eventually be able to have CAN bus on the chip. Yeah. And all that functionality can be in a chip.
I mean, it makes sense.
And somewhere in the future, you have that whole system on the chip.
Yeah. And then that one unit would probably control everything. Yeah, everything you need, you connect to that. Yeah. I mean, I'll let you go here after this, but one thing I'm surprised I didn't say earlier too is that you remember the Wi-Fi MCU that
the dongle
we were talking about connecting to the garage door to see if your door's open or whatnot.
Yeah,
you can run your printer off of that.
Yeah, yeah. The crap.
It's like an ESB something.
ESP32.
ESP32s. Yeah.
Yeah, but I just watched a video today that was like he turned it on and made his Delta printer move with it. So I was like, oh well, I guess you could use one of those too. Yeah. I mean, but that's the thing is like it's gonna get smaller and smaller, and then you really don't need too much to make it move.
Clipper doesn't require a lot of space.
No.
But for me, I guess I kind of did a bunch of things a little weirdly. To be honest with you. Was used to using Raspberry Pis, PCs, and stuff like that. Growing up. But once I started getting into 3D printing, the first printer I got already had the silent board on board, so I didn't have to change that out much. And then,
lucky.
Yeah, well, the problem is I wasn't happy with what that board could tell me.
Well, you also had tried 3D printing before, but not you specifically. You were
right. It was
near.
It was my roommate's 3D printer, and we used his printer a lot. His printer did not have the silent board on board.
So you knew what you didn't want.
So I knew what I could hear from the computer room to my bedroom, and I didn't want to hear that. All right. So I went with a silent board. But the thing is that silent board didn't give me everything I want. I'm a data guy. So I want to see all of my data points I could possibly ask for and, build on that. Because for me, I like to learn. I like to tinker. If I'm not tinkering, something's wrong. So I immediately went to Clipper. And then incorporated the Raspberry Pi into it. And then built, and this is where we go into the next generation, the second generation of MCUs that I'm used to, is getting over to the Voron. When I built the Voron, which was a giant leap, I went to the Octopus Voron board that they came out with for it, for the 2.4, that had enough drivers for every single axis and everything else. However, it is a clipper board, and for me, I did not like the fact that I had to run cable from my hot end back to the MCU. I didn't like the travel, so I added
It's a long reach too. Yeah.
an ESB CAN bus adapter to the Raspberry Pi hat that's underneath my my Voron, and CAN bust it all the way back to the hot end. So where I think it's going, I think Big Tree Tech's done a good job getting us to this point of where they're going, and further on, is they're starting to incorporate the run, Forrest, run.
So it's starting to incorporate it. He said, don't.
But
your hand signals continue without me.
yeah, well, I couldn't let a good joke go to waste. So, the one thing is I think Big Tree Tech is doing it for us. They're incorporating like the Raspberry Pi into the MCU. So it's one less thing you gotta buy.
That's
one less piece of clutter.
Yeah, that's what I see with when you showed the Kraken, and you look at some of their other setups, they're trying to handle all that stuff. They don't want you to have to go to another company or something like that.
Right.
So.
But that's where kind of
or need to go to something to figure out how that translates. Like,
right.
You should have to.
And this is kind of also where things become overkill. Is I've seen people take the 2.4 Vorons, like what I got, and instead of because they can't find a Raspberry Pi, they use a mini PC.
Yeah, I tried to use a desktop. It didn't work.
So
I mean, it can work.
Right.
It can. Yeah.
But you talk about overkill.
Yeah, this is what I was saying. Is like you get a Ferrari to take to the post office. Like, what you doing? Like, you talk about. That's when Ed was talking about using the i7. It's like, come on, man, you're getting a Porsche out here. What are you doing? You taking your kids to school?
I mean, what I really would like to do is figure out how to use edge computing.
Yeah.
And use computing in the cloud.
Some VM.
Or anything that's computational wise, data, all that type of thing.
I would say, yeah. I think we would be getting closer to that.
Well, the thing is we're almost to an hour. But the thing is yeah. But the thing is, I think that's where it kind of gets kind of fun when you start dealing with Clipper instances, because Clipper can be ran into Docker, it can be Dockerized. However, if you ever deal with Docker, you start dealing with Docker networking, it's just terrible. Everything about that is not good.
You should just do a Linux ISO if you're gonna try to do Docker. Right now,
yeah.
But the thing is there are people that are running Clipper in a containerized environment, in a virtual machine. So they're running it server based.
Right.
Because that's what I wanted to do. That's what OctoFarm is.
Right.
It's Octoprint and several of them. I mean, right now, Mainsail has the ability for you to switch between printers in Clipper with the Clipper infrastructure. So they can handle all the things really. But at the end of the day, if you want the cleanest process so that you can go in and make changes and not bring all your printers down, you need several of them.
Yeah.
Well, so when I'm saying edge computing and using the cloud, it's not for what's controlling what's happening with the printer. It's the data that I'm extracting from the printer to use to make the process better.
That makes sense.
And whether you do that localized or you use it in the cloud, what it gives you is the opportunity to do analytics.
And the good thing is that most of these machines can do MQTT, and they can do offloading of log files to another repository. Especially if you have it hooked up to the network drive, you can drop it in the network drive and keep going. Most of the new printers, most of your newer, and this is where you get back into your MCUs. Most of your newer MCUs have an RJ45 connector on there, so they can be networked. So from there, edge computing is one thing where it actually can get pretty easy.
It makes sense. I don't think that's very far.
But the thing is, especially if you're dealing with multiple printers. I think that, especially if you have all RJ45 back to a node, and you have them all hooked up back to a central storage device, and you have all of their logs there. You throw all their logs into Kibana, and you can search every single thing that's going on with your printer all day long, day in, day out, and you can eventually search it. But the good thing is like what he was saying, what Champ was saying about Octofarm, is Octofarm has all those logs already. You know, if you're using Octoprint, which I'm really hoping for, you know, the love of all things holy, is they figure out a way to do that for Clipper.
You got to code it in. What I've learned with the two is that Octoprint is really hey, here's your whole Grand Slam breakfast, everything that you need in a breakfast, and then Clipper's like, yeah, you can get eggs. You have to make your eggs though. Yeah, you can get some bacon. You're gonna have to code that in over here.
Right. But you know, and the thing is you know, one's for more hands-on, the other one's not so much.
Yeah. To be honest, and I don't want that to restrict either. Either you can build on.
I don't want to see, you know, the fact that we got kids out there, you know, especially like STEM kids and stuff like that, who are extremely smart with these 3D printers, who understand Clipper, who understand all this, you know, have to, I can't manage my print farm, so, well, I'm going to go to a Bamboo, you know, because Bamboo can do it all from the Bamboo cloud, you know, instead of saying, hey, build a couple, you know, show how well you like STEM by building a couple, you know, smaller Vorons and networking them all together and run them in a print farm. That Voron's going to be more accurate than that Bamboo is 95% of the time.
I think some of the problems
That's going to get some
when we
blasphemy.
start,
If you built it right.
something I see is we say limitations, but the limitation is the person.
Right.
If you want a turnkey system, yes. If you're trying to get kids to become engineers, then you give them that problem and say solve it.
Yeah. Now
that's what STEM should be. Not hey, here's a kit, push the button. Hey, turn the little dial, and then the clown pops out of the box.
Yeah.
That's not it. That's not educating anybody.
I hated Jack in the Boxes.
Now, the funny part is you know, we talk about the fact that, you know, we start building software when we get bored, right?
Yeah.
And this goes along with eventually somebody's going to build it, probably one of us, because we get bored too easy. I was working on my paper for this class I was in, and I wrote a Python script to check my paper against the APA standard.
There you go.
Because I got bored.
So you don't have to audit it.
But, you know, the thing is somebody's going to build it, like you said. I think somebody's going to take Octoform and repackage it and go from there, because technically it does have an Octoform plugin for Clipper.
All it takes is someone that's
Octo
like,
Clipper.
this is close but not what I want.
Yeah.
Like, close but not exactly right. And that's kind of how Clipper, that's, you know, our slicer that we use, and we're way off topic now, but our slicer that we use, Super Slicer, is just like a branch of the Prusa slicer software that they usually use, because we were like, yeah, this is pretty good, but let's get a couple more things in there.
So for me, like I said, I totally see all these things we're talking about, like you having to do this adjustment, that adjustment. It's going to go back to like when Windows was like, hey, you can customize this screen. And the reason it's going to get that way is because it's now a demand. And since it's a demand, just like people now can get streaming by plugging in a Amazon device in their television and putting in a password, connect to the Wi-Fi, and let's go. Mm-hmm. That's where 3D printing is going. Yeah. For consumers.
Smart printing.
Not for commercial, not for industrial, not for the space industry, not for military. But for education, consumers, hobbyists, prosumers, that's where it's going. It's going to be, you do a little bit of setup, and then you can either use voice recognition, or you can say, hey, type this into some AI model. Hey, AI model, can you do this? Yeah. And the AI model say, okay, this configuration works. Mm-hmm. Yes or no? You say yes, the configuration is put in place, and you go. It's going to be a plug and print system.
It should be. It should be. I mean, that's what everybody's going towards, and we're trying to like get to a process that everyone can kind of follow. That's why we teach them kind of how to do these things. Yeah. But yeah, full circle.
Yeah, you know, and everything's back to the same, back to square one again. You know, but the thing is I think that you know, before we get too off kilter here, I think that'll do it. We've about to hit an hour.
Yeah, because we stopped talking about MCUs and just kept going.
Well, we did, but we didn't.
Yeah, it's kind of similar.
We stopped talking like MCU is this 3D printing. We basically said, hey,
What is it?
here's everything that encompasses MCUs.
But, the one thing is I want to leave everybody this, at least this final thought before we get into closing, is if you do have an MCU and the MCU has an issue to it, e-waste it, bring it to an e-waste recycling location, and get rid of it there. Don't throw it in your trash. Don't do anything like that. Bring it to e-waste, same place you bring your laptop, and drop it off there, and they'll take care of it.
We'll give you Ed's address so you can start sending them to him.
Yeah, his wife would love that.
He's like, I'll take them.
Works for me. You know what the scrap rate is for that?
Hey,
I know what to do with them.
Yeah, but
There you go.
All in all, I want to say thank you to everybody who's listened in. Y'all freaking again surprised me once again. And we're up to 2110. We were a little while ago. We were fighting for 2000. A long time ago we were fighting for 1. But we've made it a little bit further than that now. And I just want to say thank you. Thank you for everything. Thank you for tuning in, listening. Wasting your time with us. And we probably got other things better to do. But we want to say thank you, and we hope that y'all get something out of this, just like we do. Have a good laugh, have some fun. Let us know what you're working on. Send us a message. Let us know what y'all are working on. DM us, send it to us, whatever. And also, if you're on Discord, you'll find us also on Discord. Vulcan R Tech on Discord, you'll find us on there. So go check us out. If you see us around, say something. So that just leads me to again say thank you. We're definitely gonna be working on some other things. You may see some more STEM stuff come up, and also let us know. And I'm gonna push this poll probably on X soon. If y'all want to do a live stream one evening, and we do like a happy hour live stream where we just kind of talk about STEM stuff, and we kind of have a discussion about where it's going, and y'all jump in and let us know what you think. I'd love to have people from all over the world join in. I got listeners going all over the place. So, I'd really hope people want to join in. But, that's here nor there. Thank you. And I'll turn it over to the guys.
So, I would like to issue a challenge to our audience. All of our 3D printing, prosumers, consumers, education, STEM guys. Next year, we want to do once a month basically a parade of prints. So we want images of something you've printed, so that we can have a gallery of the prints that have been done from our audience, so we can kind of see what everybody's doing. I think that's something we can do as a community. I think we've grown as a community, and I think it's something that we can do to show, hey, get interested in 3D printing. Here's some reasons why. Here's some gallery images, and if you have some prints and STL files you want to share, hey, we can even try to set up something where you guys can share some STL files you want to. We'll have to figure out the logistics of that, but maybe it's something we can look at. But the gallery, I think we definitely can do.
It's free marketing.
But I appreciate all the support, and keep listening.
Same thing, guys. I think input's invaluable. We need to kind of be involved with the audience as much as we can. So anything you guys have, I wouldn't shoot anything down. You got an idea, send it our way. Discord's probably going to be an easy way to get it to us, but you have the website. Check out Printed Heritage and those things. Of course, it's that time of the year, Christmas time. It's easy gift to give. You can get a lithophane and make a nightlight if you need to, and send it to your family. So it's something that's thoughtful, something that's custom, it's not going to break the bank. So check it out, see if you like anything, and stay tuned, guys. We've got a few things coming down the pipe. So, and once again, thanks.
All right, y'all. Have a good one. Bye. That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcan R Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.